So a competitor is running a 20-kilometre race. She runs each of the first 4 kilometres at a steady pace of 6 minutes per kilometre, and after the first 4 kilometres she begins to slow down. In order to estimate her finishing time, the time that she will take to complete each subsequent kilometre is modelled to be 5% greater than the time she took to complete the previous kilometre. So using this model, part A says we need to show that her time to run the first 6 kilometres is estimated to be 36 minutes and 55 seconds, and this is for 2 marks. So to work out the total time for the first 6 kilometres, we need to have a look back in the question at some of the detail. We see she runs the first 4 kilometres at a steady pace of 6 minutes per kilometre. So we can write this down here. We can say, okay, so this would be 6 times 4, because this is the kilometres, and it's going to take 6 minutes to run each kilometre, so it will be 24 minutes in total. However, after that, things change a bit. It says back up in the question that she begins to slow down, and the time she takes to complete each subsequent kilometre is modelled by 5% greater than the time she took to complete the previous kilometre. So adding on to this, we say, okay, it took her 6 minutes to run the previous kilometre. However, it's 5% more than that, so we're going to times it by 1.05. Okay, so far we've got 4 kilometres here, and we've got another kilometre here, so we're going to need to add 1 more kilometre to get to the total time for 6 kilometres. But again, she slows down by 5% again. So it's going to be 6 times, and we need to times it again by 1.05. So we can write that and say 1.05 squared. So working that out by putting it into the calculator, we get 36.915 minutes. However, we want to write that in minutes and seconds. So we know that equals, so we're going to have 36 minutes, and so we got less than another minute, so we got some seconds. So we got 0.915 of a minute. So that's going to be 55 seconds. And the reason for that is because we've got 1 minute, which is 60 seconds, times by 0.915, which equals 54.9, which is approximately 55. So that's great. That's the answer to part A. Moving on to part B, it says we need to show that her estimated time in minutes to run the rth kilometre for R is between 5 and 20 is 6 times 1.05 to the power of R minus 4. And this is just for 1 mark. So we're just going to write down what we know. So we know for the 5th kilometre, it takes her 6 times 1.05. I'll write that to the power of 1. And we see, because we worked that out earlier, it's here. So she takes 6 minutes, and then it's 5% more than that. So we're timesing it by 1.05. And here we also worked out the 6th kilometre is this here. So the 6th kilometre takes us 6 times 1.05 squared. So it would follow that the 7th kilometre would take 6 times 1.05 to the power of 3. And if we see and work out if there's a common pattern here, we've got, okay, for the 5th kilometre, if we take away the power here, minus 1, we get 4. Okay, the 6th kilometre, we take away the power, we get 4. And the 7th kilometre, we take away the power, and we get 4 as well. So we've basically shown it there. So therefore, it follows that the time taken for the rth kilometre is 6 times 1.05 to the power of R minus 4. And lastly, we're going to take a look at part C here. So we need to estimate the total time in minutes and seconds that she will take to complete the race. And that's for 4 marks. So we know that she runs at a steady pace of 6 minutes per kilometre for the first 4 kilometres, and we previously worked out that that was 24 minutes. So we can write that down here and not worry about that. We can just say total time at the start is going to be 24 minutes. And then we're going to add on top of that. And what we're going to use is this general formula that we created in the previous part. So if we do the summation of that formula, so 6 times 1.05 to the power of R minus 4. And well, here, this is the first 4 kilometres are already taken care of here. So this is 4 kilometres. So for this summation, we want to go from R equals 5, because we look at the 5th kilometre, and it's a 20 kilometre race, so we want to go up to 20 kilometres here. So now the last thing to do is evaluate all this. This right here is actually a geometric series that we're going to evaluate. And to do that, we need to know a few things. So we need to know the first term. Well, the first term is going to be when R is 5. So 5 minus 4 is 1. So that's 6 times 1.05, which equals 6.3. And the common ratio is 1.05. That's because for each kilometre that she's running, we're multiplying by 1.05 because she's taking 5% more time than in the previous kilometre. And we can also say here that n is going to be 16. That's because we've got 20 kilometres in total. We've got 4 kilometres here. So this is evaluating 16 kilometres. And this is basically how many terms there are. So for each kilometre, we've got a new term. So that means n is 16. And then we can evaluate this using a formula from the formula booklet. It says the sum is a multiplied by 1 minus r to the power of n all over 1 minus r. So doing that, we get that the total time equals 24 minutes plus 6.3 multiplied by 1 minus 1.05 to the power of 16 all over 1 minus 1.05. 173.042 to 3 decimal places. Just work that by putting that in the calculator. So that's minutes. And that equals 173 minutes and 3 seconds. And just like earlier, we worked that out by doing 60 multiplied by 0.042 and then rounding to the nearest second. So looking at the mark scheme, see where we get the marks. For part A, we get 1 mark for this line here and 1 mark for the correct answer. So for part B, we get 1 mark for all this working. Essentially, what we've got to show is that we're making the link between the rth kilometre and the index here. So that's what we're showing here. And finally, for part C, we get 1 mark for this line here. We get another mark for this part here. So using the correct formula from the formula booklet. And we get another mark here for adding it on to the 24 minutes to get the total time. And we get the 4th and final mark for the correct answer.